Hello everyone. In this video tutorial, we'll learn about the threads in Java. A thread is a concept which makes advanced benefits in terms of efficiencies for each and every modern world programs. So a thread can be considered as a part of a process. A process is heavyweight and the thread is lightweight because it consists of and consumes the resources which a process has, but it runs in parallel. For example, you can imagine that a thread is like a virtual CPU system in a computer, which process parts of a job of a process. So suppose a process can count from 1 to 100. Yes, to count from 1 to 100, suppose a process not count, it adds the values from 1 to 100. So this adding of numbers from 1 to 100 can be divided by 10 threads. And the first thread will make the sum of 1 to 10. The second thread will make the sum from 11 to 20. The third thread will make the sum of 21 to 30. Fourth thread will make the sum of 41 to 50 and so on. Yes, in this way 31 to 40 or then 41 to 50, then 51 to 60 and so on. It will be keep on doing the same thing by dividing into multiple parts. Yes, so that is the advantage of multi-threaded programs, and Java support this multi-threaded programs. Yes, so a multi-threaded program contains 2 or more parts that can run concurrently, and each part can handle a different task at the same time, making optimal use of the available resources, especially when your computer has multiple CPUs. For example, if you have i3 processor, you have 4 cores. So each core can process a thread. So 4 threads can run at a specific time in the computer, making your processing fast. The fast processing can be provided in this way. Similarly, if you have a higher range of your CPUs, then it can have 8 cores and 16 cores and so on. So how these threads can work in Java? Each and every threads in Java works on these stages. First stage is new. In new stage, a thread is just created. It's not yet started. When the thread is created, it's in the new thread stage. Now it will keep on running. Yes, before keep on running, it's in the runnable state. The runnable state of a thread is started when the start method is printed. When you call the start method. Whenever you call the start method with a new thread object, then the thread is in the runnable object. And then you call the run method. Whenever you call this run method, what happens? The thread started running. Keep one thing in mind, till the run method body is there, is executing, that time only, up to that level of the time only, the thread will be alive. After that, the thread will be dead. So after you go out of the run block of these are the system defined methods, okay? I'll come to this later. Start, run, these are the system defined methods. These are available within the thread class, which comes automatically to each and every Java program. Yes, so whenever, and you have to override the run method. So whatever is written inside the run method, only that part will be running and executable by a thread. And you no need to call run method. Run method will be automatically called after this start method has make the thread from the new to runnable state. Run method will be automatically called. You no need to call run explicitly. After the thread is running, it can go to sleep or wait mode, and it will become into the waiting stage. Yes, you can call these methods like sleep and wait. If you call this sleep and wait method, then what will happen? It will go to the waiting method, or you can end the execution when it will go out of the run method. The thread will be dead. It will be of no use anymore. This is the life cycle of a thread. So these things has been explained in detail over here. I'll give this note in the description of this video. You can see over there, you can download from there and you can get the note, and definitely if you cross verify, if you open the note in one side and watch my videos in another side, definitely the concepts will be more clear to you. We have another concept of thread priorities. What do you mean by thread priorities? A thread priority say that suppose there are 100 threads. So how the threads will be getting the CPU time? It depends on the thread priority. For example, suppose in real world example, if I give, suppose one chief minister is going through a particular job, and on the same road, many other general people with general purpose are driving or walking. Okay, so as the CM is going through that road, will give the CM highest priority to access that road. And the police will make sure that the CM's convoy passes first. Then the general people will drive through the road. Similarly, in Java, when there are many nodes, when there are many threads, we can assign the thread priority, and based on the thread priority, the threads will execute. Yes, the minimum priority is 1. The value of the mean priority for a thread is 1. Maximum priority value is 10. And the default priority, if you don't provide any priority, then the default priority it will get is 5. So the highest priority thread will get the better chance to execute. That is, it will get more privilege to execute fast. It will execute first than the other methods. Yes, so a thread with the highest priority will execute first. So for example, a system process, you can make it as a maximum priority, and a non-system process, a general process, a game, suppose a gaming process, that you can make with the mean priority. And the things which are running in terms of like the PDF, you can make, suppose, this PDF process into the normal priority. So it depends upon how you are developing your applications and which processes require more attention. Based on that, you can provide a particular priority to a particular thread. Now we'll come to the main topic, how to create a thread in Java. You have two ways to create a thread. One is by implementing a runnable interface to your class or extending a thread class. So as you can understand that inheritance is mandatory to implement thread. Without inheritance, you cannot create a thread in Java. Either you have to extend the runnable thread class or implement the runnable interface. We'll see one by one both the stages. So we'll see the first stage over here. What's the first stage? The first stage is to implementing a runnable interface. So when we implement the runnable interface, we first keep these steps in mind. That is, first you have to define the public void run, because the method will execute whenever the run method is there, and whatever the things are written inside the run methods block, that the thread will execute only. Next, you have to create the thread now. How will create the thread? Thread, then you have to pass the runnable threads object here. Yes, so a class which has inherited, that is, implements the runnable interface, that class object you have to create and pass. And then in the second argument, you can pass what? You can pass the string name of the thread. That thread will get that name. Yes, and when these two steps are done, you have to start the thread by calling the start method. If you do that, then the thread is started. Yes, and thread will start, and then immediately it will call whatever you have written inside the public void run method will be called, and whatever you have written inside this run method, that will be executed. So we'll see that how this thing is happening over here. So we have a particular small program here. It's a very small program. If you see the real world thread programs, you'll feel that time it's a very small program. So you'll create a Java project. Yes, inside the Java project, we'll give it thread programs. Yes, we are learning thread programs through this particular Java project only. Then we'll add up the classes here. New class. And you can give the name of the class as thread, test thread. And next we'll copy it again, because if I type it and show you one by one, it will be better, but it will consume lots of time and the video length will be some 2 to 3 hours. I just want to make it as small as possible. So now the thread is provided to you. See this, how this thread is created. First step you have made is that you have implemented the runnable interface. This runnable interface is available into default package, so you don't need to import any package in your program. Next thing we need to do is to create the private. These things are not mandatory, okay, but we are doing is what? One private thread reference variable we have taken. Thread is the class name, which is already available in your program because it's available in the default package. Next, string is also a class which is available in java.lang default package, and we are providing a variable name, thread name. Now this class is having a constructor, thread demo, which takes the argument of the string name, and that name is set to the thread name, and we are printing that, creating thread name. So whenever this constructor will be called, the thread name creating and the thread name will be displayed and the thread name will be obtained. In this class, we have a public void run. This is the first step actually. After implementing, after inheriting the runnable interface, this is the first step. This step cannot be ignored. It has to be written. You don't have another option. What I've written in this particular method, we have written here public void run. So we are overriding this run method, which is available in this particular runnable interface. And what you are printing over here, running thread name. So creating, I have written before when you have created the object of the runnable demo class, correct? And here we are printing running and the thread name. Now inside the try block, we are assigning this. Why you are putting inside the try block? Because these things, while creation and calling the thread methods, you should supposed to put always inside the try block, because it may generate some exception. So if you do the exception handling for these processes, for these methods of the thread, then your program will not halt. It will keep on executing because the exception will be handled. So we are printing from we are looping from I is equals to 4 to 0 and decremented by 1 each time for each iteration. And we are printing that thread, then thread name, thread, then the thread name, this variable, thread name variable you are printing over there. And we are giving a comma and we are printing the value of I. Yes, and then we are sleeping the current thread for 50 milliseconds. This value will always take milliseconds only, and sleep is the method which will make the thread into the waiting mode. Just let me show you again. This waiting mode, if you call this sleep, then it will go to the waiting mode. So that's what we are doing over here. We are trying to make the current thread to go into the waiting mode for 50 milliseconds. So you have to specify this sleep is a static method. Okay, it can be used by using the name of the thread class. So thread class dot sleep 50 millisecond. It will sleep. So while you're sleeping, actually, if it wait, then other threads can run immediately. If a thread is running, suppose if the thread sleeps, then the other thread can start execution. And in the catch block, we are printing the exception in case interrupted exception generates. In case interrupted exception generates, for the sleep method, it usually generates interrupted exception. So you are printing that thing. So if you are not, if you don't have much understanding on the exception handling, then please watch my video on exception handling. Now, we have defined another class, public void start. This start method is doing what? It is printing that, starting the thread name. Yes, and if the thread is equals to null, that is there is no thread, then we are creating a new thread by using what? This and thread name. So I showed you in the PDF that this is the second step, right? Yes, object and runnable class object and runnable interface object and this string thread name. So that's what we are doing. This will refer to the current object of the class. Which class? Runnable demo. That is required. That is what required. That means this will refer to that particular object of the class runnable demo. And thread name is the name which you are passing. That will be retrieved. And t.start is the third step. Is the third step. Yes, there is the second step. There is the second step. As we have shown into the video, this is the first step. Correct? This is the first step as we have shown into the PDF. And this is the third step. And the remaining all other codes are to support these steps. Now you have created another class test thread. From there we are creating the object of the runnable demo. Yes, and you are passing these messages over there. So this thing will be printed for sure. Yes, because runnable demo is having a single parameterized constructor which takes a string argument, and that string argument is being printed there. Correct? See here. Yes, and creating thread name will be printed there. And then we are starting the thread by using the object. So this will in turn execute this line, right? And here, if there is no object, a new thread will be created, and then that thread will call what? Start. So here actually we are doing the main step here. We are creating a thread object T. This T is reference before, na? This T is the thread reference, and we are making this object over here. A new thread, and you are starting over here. So when you are calling the start method, then what will happen? This particular thing will be executed, and then what will happen? This will execute the run method, and run method will execute 4 to 1 decremented by 1. So you have created two threads here because you're calling start twice using R1 once, another time by using what? R2. Yes, sorry, the third step is removed from here. I'll comment and write down third. Yes, so if I execute, what will happen? Two threads will run. How? One by one, because we are sleeping one thread. So haphazardly they will work. So keep one thing in mind for thread programs. If you execute it one and again, it may give you different results. That's the reason why. See, creating thread 1, starting thread 1, creating thread 2, starting thread 2. This creating thread 1 is coming for what purpose? Whenever we are creating the object, it's displaying creating thread 1. So this line 31 is displaying this. Yes. And this line 33 is displaying this. Yes, immediately after that you started, right? So it is displaying starting thread 1. Understood? And then this thread is creating and calling the start method. So before these things are started, we have started thread 2. It will happen haphazardly. Again, I'm telling you, if you execute the same program in twice, thrice in the same laptop or same computer, it may be giving you different results because you don't know in which order thread will start execution. It will be haphazardly done by the system, and it's very much system specific. If you run in one system, it might be different than the other system. So running thread 2 and the thread is now started. Thread 2, 4. See this? The values are printed. Running thread is coming from where? Which line? Running thread is coming from this line. See, we are not calling the run method. Nowhere we call the run method, correct? Run method will be called automatically. Whenever the thread will be created, immediately it will go to the run. And whenever it will come to the end of the run and go out of the run method, the thread is gone out. So we are printing exiting. The thread name you are printing, and then you are writing exiting, because the thread is going out of the body of run. So if it goes out of the body of the run method, immediately the thread will be dead. So it will print exiting, and after that the thread will be dead. Yes, and see that's how it is printing. Thread 2 started first. Yes, with the value 4. Then thread 1 started. Yes, thread 2 started. Now that's why these two lines are printed. And these two lines, this line and then this line is printed first, correct? Let me show you full if you get confused otherwise. Yes, so these two lines are executing. So it is printing running thread and thread 2, 4, and then similarly we're running for running thread 1 and then 1, 4, and see this, it is decrementing for thread 1 and 2, 1 and 2, 1 and 2, it is decrementing 3, 3, 2, 2, 1, 1, and at the end when it is getting out of the run method, we are printing that thread 1 exiting, and definitely the thread will be dead when it will go out of the run method. This is how the thread methods works in Java. This is the first program on the how to create a thread using the Runnable interface. Now we'll see that how to create thread using the second option, that is extending the thread class. By extending what? A thread class. Also we can create threads. Yes. So how to do that? The same steps you have. First you override the run method and then you start. That's enough. Here one step is less. See, we'll go through this program directly and can see. No need to, because the last program you have seen, so if I give the theoretical explanation, it's not required anymore. See this. I'll see the execution first. Then I'll show you the code. See what's the difference we are making here. You are just extending the thread class. Yes, not implement interface. Now these things are, check it out, these things are quite same. Thread name is the name over here, and creating the thread name we are displaying. Public void run, we are doing the same part over here. Yes. And in the catch exceptions we are printing. Now we have written the public void start method over there and creating the thread object and calling the start. So this is the third step, this is the second step like the last method, and this is the first step to make the run method written over here. Yes. Yes, the things are all same. See, Yes, are you clear? Yes, the result is also similar. And the same result actually for this. So we can create the thread in two ways. One by implementing the runnable interface, or by by using the thread class, by extending the thread class. So we'll see regarding the thread methods now. There are a lot of the methods the thread class provides. Yes, in the thread class we have these multiple methods available. What are those? What are those? Public void start. It will start the thread. Then we have public void run. This defines that how a thread will run, how a thread will execute. So a thread can execute unless the body of the run method it traverses. Then we have the public final void set name. So set name method, if you call and pass the argument, it will set the name of the thread object. If you created the thread object already and if you again call the set name and the thread name if you pass, then the new thread name will be received by the set name method. Then set priority, and if you pass the priority values between 1 to 10, that priority of the that will be the priority of the current existing thread. Next we have the set daemon. So set daemon process will do what? It will take one boolean value. If it is true, then it will denote that the thread is a daemon thread. Daemon thread will end at the end. Public final void join. So join is a very important thing. Here we provide the millisecond as an argument. So join method is used, when there is a existing and running thread is there. That thread will call join method to join another thread actually. Yes. So the current thread which is calling the join, that will block itself until the second thread, another thread which is running in the system, that terminates, or this particular number of milliseconds are passed. There is two options. So suppose there is a thread T1. T1 called T1.join within the bracket 5000. 5000 millisecond means 5 seconds. So what will happen? T1.join within the bracket 5000 means T1 will block itself. It will not execute unless the other threads in the system executes and completes itself, or the 5000 millisecond, that is 5 seconds are over. If 5 seconds are over, then it can resumes itself. Or if before 5 seconds other threads have completed the execution, that time it will start execution. It's like a traffic signal. You are going through a traffic signal and you got a red signal, you stopped. So you stopped means you are waiting for, suppose the traffic signal is having 30 seconds of time. So you are stopping for 30 seconds so that the other cars are passed. So here is a modification of the traffic signal, is that either 30 seconds will pass or there is no car, that time you can pass even if it is not 30 seconds. That doesn't happen for the traffic signal generally, but it happens in case of join method. Then we have the interrupt method. What the interrupt method will do? It will interrupt the method. Yes, so the execution will be blocked. Yes, for any reason. Yes, that is the blocked interrupt means the thread is, it was blocked. Suppose a thread is blocked. If you call the interrupt method, then that blocked state will be removed. The thread will start continuing the execution. Is alive method is just to check it will give a boolean response you back, that is it true or false. If it is true, then the thread is running. It is alive. It is there in the system. If the thread is dead, it will give you back the false response. That's it. To check that the thread is alive or not. Yes, the previous methods are invoked on a particular thread object, correct? The following methods in the threads are static. It means that invoking one of the static methods performs the operation on the currently running thread only. So what are the static methods that there? Yield method. It causes the currently running thread to yield to any other thread of the same priority that are waiting to be scheduled. So suppose you have your thread T1 has the priority 5 and there is another thread with the same priority 5. Yes, so it will make, T2 which is having, T1 will make, if I call T1.yield, then T1 will make other thread, for example T2 with the same priority 5 in this example to start execution. It was waiting, so it will be scheduled. T2 will be scheduled by T1. Similarly, we have the sleep method. Sleep method will take millisecond as an argument, and that many milliseconds it will it will wait, and what will happen? After that only it will be start execution. So it will be like pausing a blocking and pausing a current thread for a certain time. Holds lock method. We pass an object over here. Yes, this object denotes the lock, the type of the lock we are using. It will return true if the current thread holds the lock on the given object. If the current, suppose T1 is having a lock on a file, the name of the file is ABC. So if you pass the ABC files object over here, suppose the file is represented by the ABC object. So if you call T1.holdsLock ABC, will return true if the thread T1 is holding a read-write lock on the file ABC. Otherwise it will return false. Similarly, we have the current thread. It will return a reference to the currently running thread, which is the thread that invokes this method. Yes. So it will give the current thread over here. Then dump stack will print the stack trace for the currently running thread. Yes, it is for debugging. It is required actually. For debugging in the multi-threaded application, it is required. Otherwise, we don't require much for the dump stack method. So we'll go to the program and see these methods and how it executes basically. See, we have three classes here. One is the display message, which implements runnable class. Yes, it is having a single parameterized constructor, and the message is being assigned to this message. Whatever you are passing as an argument message, that will assign to this message variable. And it has the run method overridden. So till it is while true means it will be an infinite loop, and it will keep on printing the message. Yes, now there is another class which doesn't implement runnable interface, rather it extends the thread class. Yes, and it is guess a number class. It is having a single parameterized constructor which will assign its number to the variable number. Now it has a run method. What the run method will do? It has the counter and guess variables, and it's a do while loop which will guess the number. Yes, so math.random is a math class, is a by default class. Yes, which will randomly generate some value. It will be multiplied by 100 and then plus 1 will be added, and that will be converted to integer, and the guess variable will get that value and will print into the output screen this dot get names. Get name will give the name of the current thread, space guesses will be printed in the output screen, and the guess value will be printed, some random value will be printed. So current thread guesses a particular number, and then we are incrementing the counter. This will keep on go through until the guesses are not equals to number. If the guess value is equals to number, then it will be this number, okay, which you are passing. Yes, then it will be stopped. So whatever the number you are passing, that number if matches with this random value, then it will stop, otherwise not. Then you are printing in the output screen, correct, this thread, the thread names in this counter guesses. So in this particular counter value, you are being incremented, right? So this counter value guesses the two numbers actually. So it's like a random number generation which will match with this particular guess number. So this is the main program now. There are three files, okay? The last files was named as the guess a number.java, and last was display message.java. Now we have this particular name of the file, thread class demo.java. So what this particular class is doing, this class starting with the public static void main. So this particular class will start the execution. It is creating the object of hello, which is the reference variable of the runnable class, correct, which can hold new display message hello. How it's possible? It's possible because runnable is the superclass of display message. Yes, and then this thread 1 is created of the class thread object. We are passing the hello only in the output screen. So now thread 1.setDaemon true. So this is the daemon process. This will end at the end. And thread 1.setName hello. So we are setting the name of this method as hello. You can change it. If you change it, then this name will be changed. Here both the names are same, right? You can change the name over here. Then this is the thread name, right? Hello. That can be changed. Then system.out.println starting hello thread. We are printing the starting hello thread, and it will be true if we call the start method. That's why you are calling thread 1.start. So thread 1 is started. Now we are creating the second reference variable of the runnable interface. Yes, this is a runnable interface reference type which is assigned by a subclass object, and it's possible an interface reference can hold subclass object reference, correct na, object value. So you are creating an object with the goodbye name. Here it was hello name, here it is goodbye name. So hello will have the hello name, bye will have the goodbye name, and then we are setting the another thread 2 with the priority minimum priority, and it is also daemon process, and starting the goodbye thread over here. How we are creating the goodbye thread? Starting the goodbye thread by thread 2 dot start, correct na. Thread 2 is the goodbye thread na, because in the argument what you are passing, you are passing by here this reference. Here we passed runnable class reference, correct, and then change the name to hello, given the name hello only, we can give any other name. The same thing you are doing here also. Now thread T, now we have created another thread 3. See this, by creating the object of guess a new number and passing the value 27. Yes, and we are starting this particular thread over here. Now see the join method is being used, thread 3 dot join. So it will, thread 3 will be blocked itself until unless others are not executing. Yes, that's why it will catch, it will may throw interrupted exception. Then we are catching this exception over here. If we don't catch this exception, then the program will halt. So that's why you are all the time making the exception handling, and you can understand the importance of exception handling when you go for the thread programming for sure. Now system.out.println starting thread 4 new guess a number 75 will be assigned. So thread 4 also you started. So 4 threads you are starting now. At the end you are writing main is ending. So this program is written to me. I'll not type in front of you, neither I'll copy paste from there. Is there with me. So it will be easier for you to understand and execute and see. See. Now I'll not explain this again. I'll just execute and show it to you how it works. See this. So it's big answer. It's a big response. What happened basically? By thread started, goodbye thread started. Now thread 3 started also. Now thread 2, that run method is guessing always the new value. Correct na? It is changing to integer value here. It's working this guess a number. This particular things is being run. This do while loop is being run. Each time it is guessing a new value over here. Unless it goes over there. And it's matching, correct? Thread 2 in 54 guesses. Yes, so the value is matching over there somewhere. So it is coming to this particular line. Yes, this counter. So how many times? 54 guesses has been done. 54. So these are the 54 numbers. If you count that, these numbers are 54 times it has keep on guessing. Then thread 4 has been started. Why? Till now thread 4 has not started. Why? Because we don't have any order of the thread running. Na? Any thread can run at any time. Yes. Understood. Because thread 4 has not run because thread 3 has join method. It has blocked any other to join. It's completed. Yes. Now starting thread 4. Yes, now main is ending. Again it has come to the thread 3 guesses. Then after how many guesses it got the particular number, let's check. No, it's keep on going on. Yes, and the goodbye is being printed because that thread is running now. Yes, then again it's keep on guessing. See this, how these threads are running haphazardly. See, then the correct thread 3 in 24, 248 guess. After 248 guesses, it has determined the number and it's got out. Yes, so at last which thread ends? Thread 3. Yes, because guess a number is being called by the thread 3 only, and guess a number is doing more jobs than any other. Display is not doing much things, na? It's just printing. Yes, till it is running, it's printing that message. That's it. Immediately other thread 3 is start running, and it takes much time here. So thread 3 is running is too much. See, thread 3 is running is too much than any other thread. Yes, goodbye executed for only few times. Yes, in this way it is keep on running. So there is an example of, see this, This is an example of this methods. Some of the methods I have tried to display over here how it works. Now we'll learn about the thread groups. So thread groups, we can group the threads. Yes, that is called the thread groups. Each and every thread is in exactly one group should be there. One thread cannot be in more than one groups. The advantage, what's the advantage of working with the thread groups? That you can signal them all collectively. Suppose in one group there are 5 threads. We can signal them by using the resume method, stop method, suspend method, interrupt method, etc. And all these 5 threads which staying in a particular group will be either resumed all together or stopped together, suspended together, interrupted together. Everything can be done together. That's the better thing about the grouping. Yes, we can also thread the maximum priority of all the threads. By set max priority, we can ensure that a particular group of threads do not consume too much CPU also. But the thing is that after JDK 1.2, this resume method, stop method, suspended method, all have become deprecated. So they are, right now in today's world, the thread groups can be only useful for making just plain grouping. Yes? Actually, there are security related restrictions is also there for thread grouping actually. So that's why we don't go through with much with the thread groups. So in most modern tutorials, they don't teach you regarding the thread groups. So here in this particular example, I'll try to show you how the thread groups can use. It's better to learn, right, than not to know it about it. So this is the test thread.java. Yes, now I hope that it will execute, and in the groups I'll show you to you after that. Let it execute first. Yes, so how it is giving this result, let me explain you. So print group info is a class you have defined inside the public static void main. Is this a program will start execution from here. Thread group is the class name which is used for creating the thread group. This is the name of the thread group we have given, the thread group, and object is group. So in group we are giving the maximum priority is 3. So whatever the threads will be there on the group object, through the group object reference, all the threads will have the maximum priority 3. Then you are iterating from I equals to 0 to 5, and you are on the fly creating a thread object with this group value. That is the new thread group will be there for that. The thread dash the value of I is printed. Yes, it is 0, 1, 2, 3, 4 up to this level, and the priority you are giving different priorities here right now. For the new threads we are creating now, we are giving new priorities. For the first thread it will be 1, for next thread it will be 2, then next thread it will be 0, then it will be first thread will be 1, then it will be 2, then it will be 3, then it will be 4, yes, and then it will be 5. So 5 different threads will be created on the fly, and all threads will give one higher level of priority. Yes, and the thread will get this particular name as well, the thread dash 1. At the first it will be the thread 0, the thread 1, and so on. Now print group info, start printing. It will keep on printing the groups info. Okay, what is the start printing here? This is the start printing method here. This is a synchronized method. So in another video I'll explain you what is synchronized and unsynchronized keywords are used. So thread group object here created root, and you are getting the current thread get thread group. So you are getting the thread group of the current thread, and we are spacing it into the parent over here, into the parent group we are passing. If the parent is equals to parent.getParent not equals to null, then the root is assigned with the value of the parent group, and we are printing that print group info space and root. We are giving this particular print we are calling this print group info method. Yes, with the first is the space and the next is the root as the object of thread group. That's how this method is being given the signature. Correct? The first argument it can take is the string, the next argument it can take as a thread group info. That is the thread groups object. Okay. Now if the group is equals to null, then just simply return. There is nothing in the group. Na? Otherwise, indent, yes, that is this space value here. Now we are passing then you are printing group and the group dot get name. What is the name of the group? Like for here, the name of the group was the thread group. So what's the group that you have to specify? Then the max priority you are printing in the output screen and getting the max priority by group dot get max priority. It will be 3 now for that particular thread of the object of this thread group. That's for the group object. Then we have the integer number of threads is equals to group dot active count. How many are there? How many number of threads are there? We are getting by using active count. So how many are there? That will be fetched back from there. Next, we are creating an array of thread objects, and we are passing number of threads over there, which you are retrieving from the last line. And then for number of threads over there, we are getting the group dot enumerate thread and false. Yes, this is the default available. The constructor to get it. So we are calling this actually. Yes, enumerate method. So what you are getting over there, not the constructor, method. So now here we are getting for I is equals to 0 to I less than num thread I plus plus, we are printing the thread info, indent space thread I. It will be printed one by one. Yes, then the groups, again we are creating a number of groups. We are giving the same way we are creating that. Again we are calling this thing and printing the group info one by one. Yes, the print thread info is provided over here. Print thread info is provided over here. We are passing the indent over here, that is the string, and this thread value, thread object value, and we are printing that indent thread dot get name, and priority also you are printing, and it is alive or not. So here you are using the conditional operator. We are calling that this particular thread object is alive or not. If it is true, then it will print in the output screen alive. Otherwise, it will print it is not alive. Yes, and thread dot current thread is equals to thread. If it is the current thread, then it will print it current. Otherwise, it will be blank. Yes, we are checking that it's a current thread or not. If the thread value is equals to the current thread of this running thread, then it will be printing current, else not. So that's what the program is with the thread grouping. It's a simple program with the simple methods provided over there. If you see the output, you can understand very clearly. See, the group is created, system, max priority is 10. Yes, now thread reference handler is priority 10, it's alive. Finalizer is having the priority 8 alive. Yes, signal dispatcher priority 9 alive. Attach listener priority 5 alive. Now see, we come here. Main max priority 10. Main method is a main method. Okay, main method's thread it is. Max priority is 10. Now you are printing this. Main priority 5 alive current, and the group which you have created just now, the thread group. The name is the thread group, right? It was the thread group which you have created over here in this line. It is having the mixed priority is equals to max priority is equals to 3. That's it. Yes, this is the reference handler. See, if I search here reference handler, we can get it over here only. See here, Control F, reference handler. Are you getting here reference handler? No. So system threads these are. Finalizer and all these things which I have created here. You have to go through the code again and again to see that what are the names you have given for the threads. That threads are matching yes or no over here. You're getting the max priority or not. When you are getting the max priority, it will be 10. Okay. When you are calling get max priority for this particular thread, yes, it will be what? 10. Yes. Are you getting? So in this way, we can create the different threads and its values. It will be very much useful if you go through with that one by one. Go through with that one by one, each and every line, and go through that how it is calling any other method. Yes. See. So if you have any doubt, please put into the comment section. I'll respond over there. Also, if you have any doubt, you can also just put into the link I'll display over there. Also, you can put. And these particular things, all the programs which you have executed over here, that will be provided to you in a note. In this PDF note will be provided to you in the description of the video. You can download from there and learn from there. If you like these videos, if you like the way I'm teaching here, please then subscribe my channel, like my videos. Thank you. Thank you.